So this is amorphous salt. Which salt? Amorphous salt. Okay, na? Right, all of you keep heading. Preliminary test. Preliminary test. Appearance. Preliminary test. First point. Appearance. So what is this appearance? Amorphous. What is the appearance? Amorphous. See, if this is amorphous means what is the salt that is CO3 minus 2 may be present. CO3 minus 2 may be present. Okay, na? So amorphous salt carbonate will be there. For amorphous salt carbonate will be there. Okay, na? Next, see the color all of you. Color, see, second point read all of you. Color. What is the color? Don't tell white. What we should call white them? Colorless. What we should write them? Colorless. Write the second point. Color. Colorless. Colored radicals are absent. Colored radicals are absent. So, colored radicals are absent. Next, the third one is solubility test. Solubility test. Yesterday I told you, crystalline salts they are soluble in water. Amorphous salts which they are soluble in dilute HCl. Where they are soluble in dilute HCl. Now I will show you. Now I will take solubility test. The distilled water bottle give. Now one bottle enough. Full water bottle give. Water is not there. Now look at here. So what we call this one as a spatula. What we should call this as spatula. So I am taking the given salt. So pinch of salt. Don't take more. Pinch of salt I am taking in the given test tube. Now I am performing solubility test. What I am performing solubility. So if I add water, it will not get dissolved. It will not get dissolved. See, it is getting dissolved. It is remain like white, and it is not getting dissolved. You can observe here down precipitate also is remain. So it is not getting dissolved. Amorphous salt will not dissolve in water. So where amorphous salt will dissolve? Dilute HCl. Where they will dissolve? Dilute HCl. Now I am taking the given salt, pinch of salt I am taking. Don't take for amorphous salt more salt. Why? Because if you take more salt, dilute HCl also you should add more. So that's why you should take very less. Not even a pinch of salt. Very less you should take. Okay, na? So that's why you take very little bit of salt. Okay, na? Little bit of salt and add dilute HCl. So you can observe here. This is dilute HCl. Okay, na? So dilute HCl if you add, what happens? It gets dissolved. So if you add dilute HCl, you get it. So just gently shake like this, you can get. If you want clear precipitate, you can observe here clearly. So now it will get soluble. Okay, na? Write the third point all of you. Solubility. 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 Salt plus water. Salt plus water, insoluble. Salt plus water, insoluble. CO3 minus 2 may be present. CO3 minus 2 may be present. Okay, na? Now we have to detect the acid radical. Acid radical we have to detect. Okay, na? Keep heading all of you. Problem number 2. Identification of group. Identification of group for acid radical. Identification of group for acid radical or anion. Acid radical we also call that is what? Anion. So in the given salt we have to identify the cation and the anion. So first we are identifying the anion. So first what we have to do? There are two things. If you take salt and dilute HCl, what will be getting? Colorless gas is evolved. If colorless gas is evolved, group 1 is present. If you take salt plus concentrated H2SO4, what will get? Fuming gas. What will get? Fuming gas. Fuming gas getting means second group is present. Now I am taking a given test tube. Observe carefully all of you. Given test tube I am taking. Okay, don't take more salt. Okay, na? Just a little bit of salt you take. For this given salt, what we should add? Dilute HCl later. If you add dilute HCl, what we should get? Colorless gas is evolved. You can't see the color. Gas will be coming very fastly outside. You can't see that. That's why it's colorless gas. Observe carefully. So that colorless gas is evolved means carbonate may be present. Carbonate may be present. So observe carefully. So for the given salt dilute HCl I am adding. So you can observe. See, fastly it is coming. So gas, colorless gas is evolved. Okay, so if you want here, you can observe in the test tube, some moisture content will be there. Moisture content will be there in the test tube. So like this, colorless gas is evolved. Right, all of you? Salt plus dilute HCl. Salt plus dilute HCl. Colorless gas is evolved. Colorless gas is evolved. Colorless gas is evolved. First group is present. Which group is present? First group is present. Bracket CO3 minus 2. CO3 minus 2. CO3 minus 2. Now we got. Now we want to detect whether it is CO3 minus 2 or not. We want to detect. Okay, na? So detection of first group. Look at all of you here. So detection of first group. So what we should do? Again same test. What we should do? We should take the given salt. We should take the given salt. Okay, na? The given salt we should take. Now we are detecting for this one. For this given salt, dilute HCl if you add, colorless gas is evolved. Along with that, effervescence will be coming. Effervescence means some like foam bubbles will be there. See, when you observe carefully, it will come fastly and it will go. Within seconds it will go. So colorless gas is coming along with that effervescence. Effervescence means like small bubbles it will be coming. Okay, na? So if you, when this gas is evolved, if you pass through lime water, actually lime water we are not having. When you pass this gas through lime water, it turns milky. It turns water milky. We are not going to show that one, but we will be showing the colorless gas along with that effervescence will be showing. So carbonate is present. Okay, na? Now look at here all of you carefully. So for the given salt, within seconds it will be going on. Just observe carefully. Dilute HCl I am adding. So you can observe fastly came on. Effervescence have you observed? So that effervescence is coming. Okay, right all of you. Next, detection of acid radical. Keep heading. Detection of acid radical. Detection of acid radical. First point, right? Test for CO3 minus 2. Test for CO3 minus 2. CO3 minus 2. Salt plus dilute HCl. Salt plus dilute HCl. Dilute plus salt plus dilute HCl. Colorless gas is evolved. Colorless gas is evolved with effervescence. Colorless gas is evolved with effervescence. It turns lime water milky. It turns lime water milky. CO3 minus 2 is present. CO3 minus 2 is present. Okay, na? So now we have to do confirmation test. So confirmation test is also same. So what we should do confirmation test? We should take salt and we should add 1 ml water and we should heat it and that vapor we should pass into lime water. Lime water does not turn milky. See, this also lime water is not available. What we should do, the given salt we should take. We are not doing confirmation test. The given salt we should take, and for this given salt 1 ml water we should add. 1 ml water we should add. And you take heating. So when you heat it will boil. During boiling, when you pass this to lime water is nothing but like CaO, calcium oxide. Calcium oxide, when you pass, that lime water does not turn milky. Lime water does not turn milky. So CO3 minus is confirmed. CO3 minus is confirmed. Right, all of you? Confirmation is CT for next slide. CT for CO3 minus 2. CT for CO3 minus 2. CO3 minus 2. Salt plus 1 ml water. Salt plus 1 ml water. Heat it, pass the vapors into lime water. Heat it, pass the vapors into lime water. Lime water does not turn milky. Lime water does not turn milky. CO3 minus 2 is confirmed. CO3 minus 2 is confirmed. Okay na? So now this is what anion children. So now up to now what you have detected anion. So what is the anion? CO3 minus 2. CO3 minus 2, this is the anion. Okay na? Now let us go for group table. Group table, let us go Roman number 5. Keep hitting all of you. Identification of group for basic radical. So acid radical is completed now. We are going for basic radical. Identification of group for basic radical. Identification of group for a basic radical. All of you look at here. We are having 6 groups. 6 groups we are having. In these 6 groups, any one group only will be there. So what we have to do? For this group table 1 mark. So for cation detection, first this group table you have to identify. Okay na? So now I am doing the group table. Okay na? First for cation what we have to do? Original solution you have to prepare first one. For first you have to prepare original solution. That original solution you have to keep aside. Okay na? So I am taking first, I am preparing the original solution. So given salt I am taking. So don't take more salt. If you take more salt, dilute HCl also should add more. That's why don't add more salt. Little bit salt only add. Okay na? And for this you have to add dilute HCl, not water. Original solution we are preparing. So slowly add dilute HCl. So first you add just a little bit of water. Okay na? So just gently shake the test tube. Okay na? Gently shake this test tube. If it is not still dissolved, add dilute HCl again. Don't add at a time dilute HCl. Slowly have to add. Okay na? So now almost it is getting dissolved. Still if you add some more, completely the salt has got dissolved. So this is original solution. Now you got the clear solution. Okay na? This original solution keep aside, and with this original solution only you have to perform the experiment. We are doing detection for basic radical cation. Detection for basic radical cation we are doing. Okay na? This original solution you keep on side and take. Okay na? Now in 6 groups we are having. In these 6 groups, in any one group you will get the confirmation. Okay na? So now I am taking test tube original. First all of you see original solution. Yes ma'am. Okay. Now for this original solution also you add a little bit of water. 3/4 let me add up to here. Okay na? So now this is the original solution. Now for this original solution you take in the test tube. Okay na? You take some little bit, you take original solution. What is the group 1 test? Tell all of you. Group 1 test 1. For original solution, look at in your materials. Group 1 what you had? For original solution what you have to add? Dilute HCl. What you should get? Dilute HCl. PPT if you getting means group 1 is present. So I am adding dilute HCl. See, dilute HCl I am adding the dilute HCl. Any PPT got? PPT means what? Precipitate, which is not get dissolved and settles down. That is called precipitate. So now you can't see any precipitate. All of you right? First one right? Original solution plus dilute HCl. Original solution plus dilute HCl. No PPT. Original solution plus dilute HCl. No PPT. Group 1 is absent. Group 1 is what? Absent. Group 1 is absent. Again, test is what? Next. Again, let us see the second test. Let us see the second test. Again, look at here all of you. Already, again no need to prepare children. Already it is there now. For second test what? Original solution plus dilute HCl. Already you have prepared. So you don't put the doubt again. The original solution dilute HCl already is there. For this H2S what you add? What you should add? H2S water. So you can observe here H2S water. H2S means what? Hydrogen sulfide. Hydrogen sulfide. So this hydrogen sulfide also you add. Hydrogen sulfide also you add. Okay na? So already before I have added, that's why directly I am adding hydrogen sulfide. So if you observe here, any precipitate came up? Nothing, no precipitate is there. Precipitate, nothing was came. We have to precipitate means it should get settled down. Don't say upper layer. It should get settled down. That is called precipitate. So no precipitate is there. Group 2 also is absent. Right, all of you, second point, right? Original solution plus, second point, right? Original solution plus original solution plus dilute HCl plus NH4OH take there, NH4OH from there, NH4OH, ammonium chloride, very NH4OH. So now you can observe enough. One is there. Now write along. Original solution plus dilute HCl plus H2S water, no PPT. No PPT, group T is absent. No PPT, group T is absent. Now let us perform next test. Again I am taking a test tube. I am adding original solution. I am adding what? Original solution. Original solution I am adding original solution I am adding a little bit. For this original solution, I have to add ammonium chloride. What I should add? Ammonium chloride. So ammonium chloride I am adding here. Ammonium chloride is just like here solid. So you can observe here ammonium chloride. So this ammonium chloride I am adding for the given original solution. I am adding the ammonium chloride. Along with this ammonium chloride, we have to add ammonium hydroxide. What we should add? Ammonium hydroxide. So you can observe here, this is ammonium hydroxide. So I add ammonium hydroxide. Observe carefully. So if you observe clearly, you can't see nothing here. Any precipitate is there? No precipitate is there. So group 3 is also absent. Precipitate means you should settle down here. So nothing is there. So group 3 is absent. Right, all of you? Next, third point. OS plus NH4Cl. OS plus NH4Cl plus NH4OH. NH4OH. No PPT. Group 3 is absent. No PPT. Group 3 is absent. Again, next. Again, for the fourth one, look at here, all of you. Again, I am taking one original solution. What I am taking? Original solution I am taking. Original solution. Already, before I have done now, so that all I am taking. Look at here, all of you. No. Not precipitate. There will be no precipitate. This is wrong, I think. Where the test here? No precipitate is there. So now again for the fourth experiment, where is the original solution? Again I am doing. So for the fourth one, again what I am doing? Original solution I am taking. Original solution I am taking. For this original solution, what I should add? NH4Cl, NH4OH, H2S water. So 3 chemicals I have to add, 3 reagents I have to add. So first I am adding what is there? NH4OH is there. Ammonium chloride is there. So ammonium chloride is just like salt here. So ammonium chloride I am adding for the given test tube. Ammonium chloride I am adding. Along with this ammonium chloride, ammonium hydroxide also I am adding. Ammonium hydroxide also I am adding. Along with this ammonium hydroxide, H2S water. H2S water also I am adding. So you can observe here H2S water also I am adding. So this H2S water also I am adding. Observe carefully. So you can observe here carefully. Observe carefully. There is no precipitate. So group 4 also is absent. Group 4 also is absent. All of you write OS plus NH4Cl plus NH4OH plus H2S water. No PPT. Group 4 is absent. No PPT. Group 4 is absent. Now we came to the conclusion. Now look at all of you carefully. Now ammonium carbonate also take there. NH4 twice CO3 is there. Now again original solution I am taking. Original solution I am taking. NH4 twice CO3. Right. Again look at here all of you. So original solution. This is the original solution. For this original solution, I am adding ammonium chloride. What I am adding? Ammonium chloride I am adding. Ammonium chloride I am adding for the given original solution. Original solution ammonium chloride I am adding. Along with this ammonium chloride, ammonium hydroxide also I am adding. ammonium hydroxide I am adding. So NH4OH. Here it is. So NH4OH also I am adding here. So NH4OH also I am adding. Along with NH4OH, what we should add? Ammonium carbonate I should add. What I should add? Ammonium carbonate. Here it is there, ammonium carbonate. Okay na? So look at here all of you carefully. When this, because we are getting now the test, you can observe carefully. See, here some precipitate has settled down here. You can observe here at the bottom, precipitate has settled down. Very little bit you will get. Here precipitate generally for remaining test you will get more, but here you will get very little. You can observe here down is there. If you add more, if you take more salt, more precipitate will be formed. Okay, original solution we have prepared very lightly. So according to that, the precipitate will be formed. So you can observe here precipitate is there. So group 4, group what is there here? So last group 5 is present. Group 5 is present. Right, all of you? Original solution plus NH4Cl plus NH4Cl plus NH4OH plus NH4 twice CO3. NH4 twice CO3. PPT group 5 is present. PPT group 5 is present. Now group 5 we got. Now what we have to do? We have to now analyze the fifth group. All of you see the fifth group, all of you. On the page, all of you. Fifth group. Analysis of fifth group. Analysis of fifth group. So now we want to check. So in fifth group, what type of cations are there? Ca plus 2 is there, Ba plus 2 is there, Sr plus 2 also is there. Correct or not? You see there 3 are there. In that 3, which one is present, we have to identify. Okay na? Now see all of you, analysis of fifth group, test for Ca plus 2. Test for Ca plus 2. So I am taking the original solution. Look at all of you here. Now I am testing for Ca plus 2. So original solution I am taking. Ammonium oxalate is there, see. Here all is there. Look at here all of you. Salt I am taking. For this given original solution, this is the original solution. Ammonium oxalate I am adding. When I add ammonium oxalate, you will get white precipitate. What will get? White precipitate will get Ca plus 2 is confirmed. Okay, now if I add white precipitate, will get what will get? White precipitate. So you can see here white precipitate also will be settling down here down. Slowly it will get settled down. So like the white precipitate will be formed. Okay, na? So with this calcium is confirmed. Okay, na? Right, all of you. Analysis of fifth group. Analysis of fifth group. Their matchbox is there. Analysis of fifth group. Analysis of fifth group. Original solution plus ammonium oxalate. Original solution plus ammonium oxalate solution. Ammonium oxalate solution. White precipitate. What will get? White precipitate. White precipitate. Ca plus 2 is present. White precipitate will get. So you can observe here, see, precipitate is settled down here. So Ca plus 2 is confirmed. Ca plus 2 is what? Confirmed. Now one more is there, confirmation test for Ca plus 2. Confirmation test for Ca plus 2. Now look at here. Now we are doing the confirmation test for Ca plus 2. What we should take? First we should take the given salt in watch glass. This is watch glass. You take the given salt in this. Okay na? And you add only one drop of HCl. Consonant HCl you should add. One drop consonant HCl you should add. And you should make paste. And that paste you should bring to near to the flame chiller. Then you will get brick red. What will you get? Brick red. Now I am taking the salt. So which salt we are doing now? Amorphous salt. What salt we are doing? Amorphous salt. So amorphous salt I am taking in the watch glass. So you can observe here amorphous salt I have taken in the watch glass. For this one drop of consonant HCl. Where is consonant HCl? Consonant HCl. Just you add one drop. Don't add more. Where is the dropper? Glass rod give. So this is the glass rod. So just you add one drop. Okay, one drop you add. Where is the dropper here? Dropper here. Dropper that side is just I'm adding. Look at here. So dropper not the just I'm adding. Just one drop only add. Don't add. So this is the glass rod. Okay, just you make paste. Okay, just you make a paste. Paste you make. Okay, just you make paste. Okay, and this glass rod you bring near the flame. You bring near the flame. So one more drop I'm adding. It is not get still sticked. So just one more drop. So concentration. Be careful. Don't. There we are having dropper. So like this thick paste you make. Thick paste you make. This thick paste you have to bring near the flame. You have to bring near the flame. Okay na? Near the flame you have to bring. Okay na? Near the flame you have to bring. Okay na? So now I am bringing near the flame. You will get brick red. What color you will get? Brick red. Calcium is confirmed. Calcium is confirmed. So you can observe here. So this is the okay. So I am bringing near the gas burner. Okay. So now you will observe here. Look at here. This is very important. See, this is brick red. Are you understanding? Brick red you are getting. So like this brick red, if you are getting calcium is confirmed. What is that? Calcium. If you remove again after some time it will go away. Okay, when I keep on it will come more brick red. So like this brick red will be getting. So this is the confirmation test for calcium. Confirmation test for calcium. Now this calcium is what? Cation. First we got what? Anion. Anion what we got? CO3 minus 2. And cation we got calcium. What we got? Calcium. Okay, now this is calcium. What is that? Calcium. So this is the flame test. Right, all of you? Right, all of you? Confirmation test for. Confirmation test for. Ca plus 2. Confirmation test for Ca plus 2. Salt plus 1 drop of concentrated HCl. Salt plus 1 drop of concentrated HCl. Make a paste and hold in the flame by glass rod. So this is a glass rod. So by this you bring near the flame. So what do you observe? Brick red colored flame. Brick red colored flame will get. The result is Ca plus 2 is confirmed. Ca plus 2 is confirmed. Okay na? Right, last you have to write result. Last case all of you. Result. Give all of you. Result. Acid radical or anion. Acid radical or anion. So what is the acid radical or anion here? CO3 minus 2. Answer is what? CO3 minus 2. Right there, CO3 minus 2. Next, basic radical or cation. What is the basic radical or cation? Ca plus 2. Next, given salt. What is the given salt? CaCO3. What is the given salt? CaCO3. So like this you have to perform what? CaCO3 salt analysis. This is inorganic salt. So what we are doing? We are identifying the cation and the anion. Praveen.